Advanced Financial Modeling, Topic 9, Valuing Stocks. Learning Objective number 7, we're going to value stocks using a discounted cash flow model, a DCF model. So in the last section, we talked about using a dividend discount model to value stocks, which says that the present value of all dividends is the value of the stock. That's dividends per share. However, there's limitations to that model for stocks that don't pay dividends or have a very low dividend payout ratio. And so also the relative value analysis or using price multiples can only tell you if a stock is cheaper than another stock. It doesn't tell you if it's actually a good investment. So a common method to value, and probably the most common method to value stocks, is to compute the present value of free cash flows, or also called a discounted cash flow model. And what you're going to do is you're going to calculate first the enterprise value by adding the discounted present value of unlevered free cash flows, those are FCFFs, and then subtract out net debt if cash is not needed for operations. So the first step, calculating the enterprise value, you're going to get that EV by taking the present value of FCFFs discounted at some rate R. We'll talk about later what that is, and I'll tell you later it's going to be the weighted average cost of capital. And that FCFF, if you remember, is the after-tax EBIT minus CapEx plus depreciation minus changes in net working capital. And once you get that enterprise value, sometimes we'll call that the asset value. How much I would pay, or the value of the assets of the firm, and the ability of the assets to generate cash flow. However, we do want to value the equity, and in particular, the stock price. So how we're going to do that is we're going to take that equity value, we're going to subtract debt, add cash if cash is not needed for operations, and then divide by number of shares. So you can think about this, the equity is equal to assets minus liability. So if we're calculating the value of assets, we can just subtract off liabilities to get equity. So that's what we're doing. So here is a model. We'll just go to the spreadsheet and I'll show you a completed model. And we'll go to the FCFF DCF model. So we're going to estimate the value per share of the following stock. And that stock has estimated sales next year of $1 million. When you see T equals 1, that means 1 year from today. So at the end of the current year, starting today, you expect $1 million in sales. And then it's going to grow from years 2 to 5 at 20% per year. COGS and SG&A and depreciation are going to be a percentage of sales. Tax rate is going to be 21% of EBT. Net working capital in this model is assumed to be 8% of sales, and CapEx is expected to be 12% of sales. And then I give you some, to calculate the FCFFs in period 1, I'm going to need the change in net working capital from period 0 to period 1. So here's one way of giving that to you. I tell you that debt, cash, and shares are equal to $100,000, and I also tell you that net working capital last year, you can think about that as the period just ended, was 66,667. So when the balance sheets were published, say today, based on yesterday's actuals, we'll call that time equals 0. It was 66,667 in net working capital. And then we'll use the future working capitals in periods 1, 2, 3, 4 to calculate the change. And then we'll use this debt, cash, and shares, the current value of debt, cash, and shares to then value the stock. We'll assume a discount rate of 12%, and later I'll explain to you that that actually is going to be the weighted average cost of capital. And then we'll assume that free cash flows grow forever from, say, year 6 to infinity at a rate of 3% per year. So what you see is I have sales, the initial value, 1 year from today, 2 years, 3 years, 4 years, and 5 years from today. I have COGS at 25% of sales every year. So we're just assuming that the costs, the operating costs are kind of staying at the same rate of sales. I got depreciation in this model as a percentage of sales, and then I can calculate EBIT, sales minus COGS minus SG&A minus depreciation. I then take out my taxes. I have EBIT after tax, sometimes called net operating profit after tax, NOPAT. And then I go from NOPAT or EBIT after tax to free cash flows by adding back depreciation, subtracting CapEx, which is expected to be 12% of sales, minus changes in net working capital. Let's take a look at net working capital. I told you the current balance of net working capital today is 66,000, and I say the future is going to be 8% of sales. So this is the net working capital forecast. So what I'm going to do is I'll take the change in net working capital from 0 to 1, 1 to 2, and so on. And then that will give me the free cash flows for year 1, 2, 3, 4, 5. So this is the cash that this business can generate from its assets if it had no debt or interest payments. However, we're going to value a stock or make a big assumption. We're going to say this stock lasts forever. So not just 5 years or 10 years or 20 years, but forever. And so what we're going to do is we're making an assumption called a perpetual growth rate. And we're going to assume that cash flows grow from year 6 to infinity at 3%. So here's what I'm going to do eventually is I'm going to value the cash flows in year 1, 2, 3, 4, and 5. And then I need a valuation from year 6 to infinity. So here's what I commonly do. This is the cash flow in year 5. I multiply that times 1 times perpetual growth rate. That gives me the cash flow in year 6. I then divide by R minus G, and by definition, the growth perpetuity formula, cash flow divided by R minus G, gives me the value the year before the cash flow. So if this is the cash flow in year 6, dividing by R minus G gives me the value at the end of year 5. That allows me to add it to the year 5 cash flow. So I can think about the cash flows of the firm as the following. You're going to generate cash flow in year 1, 2, 3, 4, 5. Now this is the value of cash flows from year 6 to infinity in year $5, the value in year 5. So I'll add that to the other year 5 cash flow. And now I can calculate the enterprise value by taking the net present value of cash flows from year 1 to infinity. So the enterprise value, the asset value of this firm is $7.5 million. I subtract debt, add cash, since cash is not needed in operations, I'll assume for this model. And when in doubt, don't include it unless it's otherwise specified. In other words, when in doubt, assume cash is not needed for operations, so I can use it to pay off debt if I wanted to. And then that'll give me the equity value of the firm. I then divide by number of shares outstanding today, and it tells me the stock is worth $74.07. I just want to show you one other model, and everything is the same in this model, except I'm going to change this one number right here. Instead of, this is the second most common way of doing this. We call this the terminal value, how to value the company at the end of your short-term estimation window. So, in this case, my short-term estimation window is year 5, and I assume that by year 5, the company can grow at some constant rate forever. So what I did here is a slightly different model. When all these numbers are exactly the same as above, you can verify that. But here I assume that in year 5, you've estimated that the firm is worth 8 times EBITDA. So what I did is I calculated EBITDA in year 5, sales minus COGS minus SG&A, but I didn't take out depreciation because that's EBITDA. And I assumed that the firm's worth 8 times EBITDA. So I just put that in the valuation. Now, how did I get that? Well, I had to do some kind of analysis. And what it is kind of firms in this industry that are in kind of their final stage of a perpetual growth, growing with the economy, are worth 8 times free cash flows. So, or I'm sorry, 8 times EBITDA. So I then calculate the NPV of the cash flows that includes the terminal value using EBITDA multiple. I subtract out net debt, divide by number of shares, and using this model, I get $80 a share and not 70. So this is a kind of a simplistic DCF model. You can certainly build out lots more details and go out more years if you thought that growth is going to be maybe above the growth of the economy. I'll talk about this perpetual growth rate number. So the question always comes up, do I do the estimation for 5, 10, 20 years and then do a growth perpetuity number? The basic answer to the question is you do it to as many years as you think the company will then grow at some constant rate, which is equal to or less than the growth of the economy. So if you can think of the growth of the economy as maybe 1 or 2% inflation and 1 or 2% real growth, that's a kind of a nice rule of thumb that you want to just keep doing detailed estimation till growth is equal to 3%. Now, in reality, kind of looking at this model in hindsight, if I was growing at 20% a year, here's what I probably should have done. I probably should have done years 6, 7, 8, 9, 10 and taken it from 20 to 15 to 10 to 5 to 3. And then, just using those growth rates. And then once I get to 3, I can then apply a growth perpetuity. So I should maybe gone out to maybe 9 years. But it's the model I put together. All right, so let's go back to our slides. And our slides, I want to do a quick valuation of Walmart using a DCF. And I'm going to do this really quick and dirty one. I'm going to just estimate, and I did this valuation actually in year 18, I'm sorry, 2019, right before COVID. So I wanted to keep that one in there and see how it is. And what I did is I estimated in 2019 that Walmart had EBIT after taxes of 14 billion, had depreciation and capex about 10 billion. So you can see they kind of offset each other. Interesting thing about Walmart. In year 2019, they weren't really growing very fast. And it's very common to see this when firms are not growing very fast, that depreciation is equal to capex. So that made me feel better about maybe applying a quick growth perpetuity or a low growth number and then a growth perpetuity in a few years. Because if a firm just has capex equal to their depreciation, you can think about it as just replacing the assets that wear out. As a cash register wears out, you buy a new one. As a van wears out, delivery van wears out, you buy a new one. But it's also a firm that's not increasing the number of cash registers, the number of stores, the number of delivery vans. So this would be a common thing to see for firms that aren't growing. And at that year, they had change in net working capital. We'll just call it zero. So they had FCFFs in year 2019 at about $15 billion. And then if you go to the spreadsheet, you can see what I did. I just took that $15 billion, that prior year's FCFS, and I added a couple of assumptions. And that is it's going to grow at 3.69% for 5 years and then 2.4% for year 6 to infinity. I got the 3.69 by looking at the Wall Street analyst growth rates for the next 5 years. It was 3.69. That's actually profit growth numbers, but I'll just assume that also applies to FCFFs. So if I take the 15 billion times 1.0369, they estimate free cash flows in 1 year. This would be 2020 at 15 billion, and grow it at another 3.6, and then I grow it at 2.4% forever. And I use 2.4% as a terminal growth rate because at the time that was the 10-year Treasury rate. And some people suggest that the 10-year Treasury rate is a good estimate of the long-term growth of the economy. It accounts for both inflation and real growth. So that's what I used. So if you actually look at this valuation model, this quick and dirty one, I'll take the present value of these FCFFs, and I have them here. It's just a slightly different format than the one I did on the last slide. The one on the last slide is using years across the rows, and then and cash flow, balance sheet, income statement items on the rows. So the present value of 15 billion 1 year from now is going to be worth 14 billion. I take the present value of those 5 cash flows, actually 6 cash flows, 1, 2, 3, 4, 5, 6, and then I assume I do a growth perpetuity that I take the cash flow in year 6, multiply times the perpetual growth rate 1.024, that makes it the cash flow in year 7, divide it by R minus G, that gives the value in year 6, and then I discount it back for 6 years. So I wanted to show you this because it's the second most common way of laying out a valuation model, is to just take care of the free cash flows in your estimation window first, and then add the present value of cash flows for that infinite period. In this case, year 7 through infinity. And then that gives me the enterprise value of Walmart. I subtract net debt. At the time in 2019, they had 66 billion of net debt. Divide by number of shares, and I get a stock price, which is a reasonable estimate of the stock at that time. And I also did a data table showing the sensitivity. All right, so I just wanted to show you that model, just slightly different, and you can see that actually if you go back to the spreadsheet, you can see the details. And then I also again, here's the model we just did. All I did is I replaced the terminal value here, that $360 billion, which is that growth perpetuity. I just simply replaced it with an EBITDA multiple. I assumed that I estimated the year 6 EBITDA by growing the year 2019 EBITDA, and then I multiplied times 33, which is an estimate it was roughly equal to the S&P 500's EBITDA multiple at the time. So again, all I'm doing is replacing this one valuation here using a terminal value with this one here, which is 32 times EBITDA in year 7, discounted back 7 years. And then I get a new valuation for Walmart. So again, this is not a model I'll give you an assignment on. It's going to look more like this one, but I want to show you how you can also do kind of a quick and dirty for firms that are pretty close to their steady state FCFFs. Couple notes here. Net working capital in accounting is usually defined as current assets minus current liabilities. However, in valuation, net working capital will exclude any kind of short-term interest-bearing accounts. So I would exclude, say, the short-term debt or the current portion of long-term debt, and in current liabilities, I'll exclude that. And I'll also sometimes exclude cash if cash is not needed for operations. The thing to be careful with the discussion of cash, if cash is not needed for operations, do not put it in net working capital. However, when you go to value the stock, you want to then subtract net debt or debt minus cash. So if the cash is not needed for operations, the way you put it in the valuation is you use it to pay down debt. If cash is needed for operations, say it's a business that needs lots of cash in the cash register and to pay bills, well, then you put it in net working capital. It's going to reduce FCFFs, but then you don't use it to reduce debt values in the final estimation of stock. One quick thing that comes up a lot, we have two measures of free cash flows: FCFFs, unlevered free cash flows; FCFEs, equity cash flows or levered cash flows. The question is, why can't we just use FCFEs? Well, you could. You could take the present value of FCFEs and discount it at the CAPM cost of equity. And then at that point, you can just divide by number of shares and you can get an equity valuation. Maybe add back debt if cash is not needed for operations. So while this seems to be more direct than what we're doing, and actually it's much more difficult to actually estimate FCFFs over time. Because think about FCFEs over time. FCFEs require you to calculate net income, which is pretty straightforward, at least the current value. Subtract, add depreciation, subtract CapEx, and subtract changes in net working capital. However, for FCFEs, you have to estimate debt issuance or repayment. And then that's going to have feedback on the interest and net income line. So the question is, if I needed to estimate FCFEs for Walmart for the next 5 or 10 years, I'd have to think about, well, if they had extra money, are they going to use it to pay down debt? And if I do that, are they just trying to maintain their current DDE ratio? So it's actually quite complex to estimate FCFEs over time because you have to estimate debt balances, and then you have to estimate interest rates over time to get new interest payments. So in general, you just take the present value of FCFFs, and then how you account for the leverage in a company and its valuation is through the discount rate. What we'll learn later in the next topics is if a company uses a lot of debt, it's going to affect their weighted average cost of capital, and that's how it affects the valuation of a stock. So in this topic, we talked about how to value stocks using DCF, discounted cash flow models. In the next one, we'll talk about simulating correlated random variables.